Combinatorics exercise. Combinatorics is just the mathematics of counting the number of states some kind of system can be in. That's what we're trying to do. We're trying to count the number of integer solutions. Combinatorics, it's in a course called discrete mathematics at a lot of the colleges. Okay, combinatorics, the mathematics of counting. I think it has a slightly broader meaning than that. But anyway, we're trying to find the number of integer solutions. Y'all, integers are just like 1, 2, 3, 4, 5 combined with 0, and then the negative counterparts, -1, -2, -3. So we're looking for all integer solutions to this equation where p is a prime number. Okay, so we're going to count them. That doesn't mean we necessarily have to find them. We can if we want, but we want to count the number of distinct solutions. All right, so this is similar to a special case that I worked recently where we start out about the same. All we do on this very first step is just factor an x out, okay? And then that's all that happened there. And then we observed that there is a binomial factor 1 plus y in this very first step. We see we can get that same binomial factor by adding 1, here to both sides. In other words, do a +1 here, and then a +1 right here is all we did to change p minus 1 to p. And so what we end up with is a common binomial factor. And again, this 1 plus y, it's useful to think of a 1 being in front of here. Okay, and again, this 1, if you start with this, is this 1 right here. Okay, so what we have here is an easy to count circumstance here. We have 1 plus y times x plus 1 is equal to p. Remember, y and x are all integers. And so you see p, since p is what it is, it's a prime number. It only admits 2 factorizations. Namely, it can be equal to 1 times p, or it can be equal to -1. And that's an easy to forget thing on something like this. Okay, and you can see that's all we've done right here is just equate the factor pairs. And notice right here, I just did it in reverse. Really, the values are the same because this thing is very symmetric. But you can see right here that this would correspond to a solution. This would correspond, all 4 lines would correspond to a single ordered pair solution. So the answer to the question is there are 4 solutions. And that completes what we're doing now. I'll do one just special case. 4 solutions is all you can have. You have exactly 4 solutions is the answer to the question. All right, so this is the answer to the question. Now let's just take a look at maybe the special case where p is 73. 73 is a prime number. So you can see right here that would correspond, if this were 73, that would be -73. So you would have -74 for the y coordinate. -74 right here. And y'all, what I did is just, sorry, that's 73. 73. And so if you have 73 right here, that's -73, subtract 1, you get -74 for the y coordinate. Then what happens right here? -2 for the x. Just -2, right? Because that's just equal to, -2. So this would be one of the solutions for p is equal to 73. And again, y'all, I just picked this particular line because I had some room to write. So that would be a solution if p was 73. But we were only supposed to count them, and so we got 4. I better make that plural. 4 solutions. And so the answer is 4. I don't know why it does this. This thing's kind of a piece of crap. Now, notice it's 4, but the octopus up here is throwing 5 things, or whatever that is. Frozen fish, maybe? Okay, thanks for viewing.